right, guys, let's knock out this review, test 11. Here we go. First three, find the exact value of the expression. These are all inverses. Number one says inverse sine of square root of 3 over 2. It's asking you where is sine square root of 3 over 2? That happens at pi over 3. Number two, inverse cosine of negative 1/2. Where's cosine negative 1/2? That happens at 2 pi over 3. Remember, for cosine, you can use quadrant 1 and 2. Sine, use quadrant 1 and 4. Inverse tangent, use 1 and 4. Tangent, where's tangent square root of 3 over 3? Well, because there's two 3's, it's got to be at the pi over 6. Number 4 says use a calculator to evaluate or approximate. Hit inverse second cosine, inverse cosine of 1/4. Hit enter, and in degrees, it'd be 75.5 degrees. If you want to go radians on that one, just change your calculator to radians, which I'm doing right now, and hit the same things. Inverse cosine of 1/4, and in radians, it'd be 1.3181. It didn't really say which one to use, so either one is fine. Find the angle in degrees, round to one decimal place. Here's my theta right here. I'm looking at the opposite and the hypotenuse. Opposite hypotenuse is sine, so I'm going sine theta is opposite over the hypotenuse. So to find, anytime you're looking for an angle, whenever you don't know the angle, that's inverse sine. So I'm going inverse sine, 30 over 70. I'm getting it says in degrees, I'm still in radians, sorry about that. Change back to degrees, this is live TV, sorry about that. So I'm gonna go inverse sine, 30 over 70, and I'm getting 25.4 degrees. Number 6, find the exact value of that expression. It says sine of inverse cosine of 12/13. That is a very famous triangle, by the way, 12/13. So this part of the problem, the part I just underlined, is basically saying where is sine 12/13? Well, sine is adjacent over hypotenuse, so right there is where sine is 12/13. Sorry, cosine is 12/13. Now, because it's a famous triangle, I know that's a 5, 12, 13, which means my sine of that triangle where cosine is 12/13 is 5/13. So your answer is 5/13. Number 7, 8, 9. Law of sines. Solve the triangle. So, see what we know here. Would not hurt to draw these triangles, by the way. And you can get away without doing it sometimes, but not a bad idea. So let's go A, B. Let's go C up top. It says A is 52 degrees, which is right here. B is 70 degrees, and little b, which would be over here, is 56.3. Okay, so what I need to find out is I need to find out what little c is, big C, angle C, side A, and side C. All right, what I know, I'm lucky I have these. They gave me those opposites right there. So I'm going to say 56.3 over sine 70, those are my B's, equals little a over sine 52. And I'm going to solve that proportion. I'm going to cross multiply these two. On my calculator right now, I'm going 56.3 times sine 52. And then I'm dividing that answer by sine of 70. Sine 70. And I'm getting 47.2 for little a. So that's 47.2. Also, I should have done this first. Capital C, I can just subtract those two angles from 180, the 52 and the 70 from 180. Figure out what's left over. Angle C is 58 degrees, which is good to know. And so what I'm going to do is I'm going to use this again. I'm going to use the sine 56.3 over 70, because I know that for sure. And that's going to give me little c over sine. Going backwards here. This is a good video so far. I'm glad you're understanding and patient and those kind of things. So let me go back here even further. So sorry about all this. I'm gonna do how I did the last problem. This right here. So I'm gonna go 56.3 over sine 70. Sorry about that. Equals little c over sine 58, because now I know that that's 58 degrees. So I'm gonna punch in the calculator, and I'm getting 50.8. Okay, so there's my three answers. There's the rest of that triangle. I'm sorry. That's all I can say about that. I kind of blew that one. Okay, let's try the next one real quick. I think something bad may be on the verge of happening, like the problem is going away, stuff like that. Okay, there we go. So number 8, I'm gonna make this a little bit bigger here so we can draw triangles and things, because you never know what might happen here. So I'm gonna have same kind of triangle again. Got angle A, which is 125. I need to draw that a little bit better. 125 is actually obtuse. 125, side A is 20. Let's go B here, C here. What else do we know? Side C is 45. So here's what I know this time. I know side angle, or ASS, sorry, angle side. Remember, this is a pain because it could be no triangles, it could be two triangles, or it could just be one, and it's all based on the angle. Okay, so let's just go through this thing. I'm gonna use what I know. I know sine of A over little a. So I'm gonna go sine 125 over little a, which is 20, is gonna equal sine C. I've gotta find C first because that's the side they gave me, 45. So I'm gonna cross multiply here and divide and see what I get. Okay, so here's the deal. When I cross multiply and divide, I got 1.843092. I kept on going, but here's what I know. I know if I do inverse sine here, the domain is between -1 and +1. There's no way. Yeah, I can't even punch my calculator. I'll do that right now. If I go to the second sine of 1.843 on my calculator, hit enter, it says quit. It says error domain because it's not a domain, which means there's no solution here. That is not even a triangle. Those numbers that they gave me right here, there's no way you can make up a triangle using those sides. So that's what that means. So I don't know. I'm not saying this problem on your test tomorrow is going to be no solution, but there could be. It could be two solutions. All right, let's look at what happens on the last one here. Okay, number 9 is what I was talking about, meaning the last one of these is what I was trying to say. I think it's giving me the same type stuff here. So let's see what I got. Okay, A, I don't know, but side A is 26. Let's go C up here, it's 29 degrees, and side C is 15. So again, look what I got. I got side angle, or angle side. It's a pain in the angle side, so let's work through, see what happens again. So I gotta use what they gave me. I gotta use sine 29 over 15 equals sine big A, which I don't know, over 26, which is side A. So again, I'm gonna multiply those out and divide and see what I get. Maybe no solution again, only one way to find out. I'm gonna punch it in and see what happens. Okay, good news or bad news? I got this, I got 0.8403, and I say good news or bad news because I can do inverse. Because that's less than 1, that would work. So I'm gonna go on my calc, I'm going second sine of that answer of 0.84. I'm getting 57.2 degrees. And if that's 57.2, I can obviously figure out big B right there, subtracting them from 180. But before we do that, we need to figure out if there's going to be two triangles or just one triangle. Anytime it's side angle, it could be, remember, it could be no triangles, one triangle, or two. So what I'm going to do is, because inverse sine is this, remember, inverse sine is positive in quadrant 1 and quadrant 2. So I'm going to find the quadrant 2 value of this and see if there's another one. Okay, so if I do, and the way you do that, obviously, you subtract that from 180. So I'm doing 180 minus the 57.2, and I'm getting 122.8. Now, side angle C, we already know what angle C is, 29 degrees. And because I know that means I think this is possible, because if I do 180 minus 29 minus 122.8, I'm getting 28.2 for B. So that's going to be my case 2. And my case 1 is going to be over here. Angle C again. C is 29 degrees. Big B, in this case, is going to be 180 minus the 57.2 minus the 29, which is going to give me 93.8. Okay, so 2 different cases here. And I found all I'm lacking, now that I have all 3 angles on both sides, all I need is my side B on both of them, and I have it. So what I'm going to do is I'm going to use what they gave me again. I'm going to go on case 1, I'm just going to go sine, here I go, I'm going sine 29 over 15 equals sine 93.8, which is the B over little b. I'm just going to cross multiply real quick and divide that. 15 times sine 93.8 divided by sine 29. That's giving me 30.7. 9. I'm going to do the same thing over here. I'm going sine 29 over 15 equals sine of, except this case, to get little b, I'm going 28.2 over little b. And cross multiply again. So I'm going 15 times sine 28.2 divided by sine 29. And I'm looking at 14.6. So there's both cases, both triangles. There's case 2, here's case 1. Hope that makes sense. So this part of their test is probably definitely going to be the longest part. So I hope that made some sense. Come see me tomorrow if you need to. We'll get through it. All right, number 10 says find the exact value of the trig function. First of all, cosine 330. Remember, find the reference angle, which is 30. Every time you do cosine 30, that's automatically square root of 3 over 2. And then go back and think about it. 330 is in quadrant 4. Cosine is x. X is positive in quadrant 4, so it's positive square root of 3 over 2. Secant 3 power 4. I don't know secants. Secant's reciprocal of cosine. Cosine of any 3 power 4 or any power 4 is square root of 2 over 2, which means secant's reciprocal to that. So I'm going to flip that like this. Take the root to the top. Take the number on the bottom. The 2's cancel. That's a lot of work to get to square root of 2. Now it says 3 power 4. Think about that. That's really 3/4 of the way to pi, which is in quadrant 2. Cosine is x, which is negative in quadrant 2, so it's negative square root of 2. That's a good one. Number 11, find the values of the trig functions given that information. Secant is 2, and it's in quadrant 4. If secant's 2, that means cosine is a half. I already know what the rest of them are, but I'm going to act like I don't. Remember, cosine squared plus sine squared is 1. If I square cosine, it's going to get 1/4 because 1/2 squared is 1/4. I'm getting sine squared equals 1. If I move that 1/4 over and subtract it from 1, I get 3/4. And if I take the square root, I get plus or minus the square root of 3 over 2. Now, the reason I knew that was going to be the case is because cosine's a half. 1/2 and square root of 3 over 2 always go together. But this is in quadrant 4, and sine is y, which is negative in quadrant 4. The cosecant is, I'm going to take reciprocal of the sine, take the root to the top, take the number on the bottom. And then we have tangent. Remember, tangent is sine over cosine. In this case, it'd be negative square root of 3 over 2 over 1/2, which is just negative square root of 3, which means my cotangent, if you flip square root of 3, you take the square root to the top. I forgot the square root symbol. Square root to the top, number on the bottom, there's your 5. Number 12, a building casts a shadow 250 feet long. Find the height of the building if the angle of elevation of the sun is 33.2 degrees. These are all right triangle problems. Remember, theta, your angle of elevation must touch the horizontal. So I'm going to put the angle down there. The building, we don't know what the height is. We do know the angle is, the theta angle is 33.2 degrees. And we know the shadow is 250 feet long. Now, shadow, guys, is on the ground. Please don't forget where shadows go. They go on the ground. So if I'm looking at my triangle and my angle, I'm looking at the opposite and adjacent. So it's tangent. So I'm going to go tangent of 33.2 degrees equals the height over 250. And to work that out, I'm just going to multiply 250 times tangent 32. And I'm getting 156.2 feet. That's a 0.2. 156.2. Let me do that again. 156.2 feet. That's a little bit better, but not a whole lot. Number 13, tell if it's even, odd, or neither. First of all, I know it's not odd because the exponents aren't odd. It could be even, may not be. The way you tell is you plug in a negative x. So where I see an x, I'm going to put a negative x in there. Put a negative x in here. I'm just going to take one step and work all that out. And if you raise a negative to an even power, it changes it back to positive. Again, negative to an even power changes it back to positive x squared plus 7. So I'm going to look at this, ask myself, is that the exact same thing I started with? Yes, it is, which means it is even. You don't have to check for odd, again, because the exponents are not odd. You could also punch that in your calculator, and if it's even, it'll be your graph will be symmetric with the y-axis. If it's odd, it'll be symmetric with the origin. Last 3. Using the graph, find g of negative 4, okay, g of 0 and g of 2. Negative 4 is right here, so the graph at negative 4, g of negative 4 is going to be whatever the y-coordinate is there, which it looks like it's at 3. If I find g of 0, 0 is right here. The graph is down at negative 2. And if I do g of 2 looks like it's going to be at 1, because that's where the filled-in circle is. 15, using the graph, find the domain and range. Domain is how far left and right it's going. So the domain is bracket -4 to +4 for sure. And the range, how far up and down is it going? Is going down to -2. And it's going up to 3. And 3 is going to have a bracket. I know you look at this point and thinking, well, but it's empty. Yeah, but this one over here, that's full. So that's what makes the difference. Last question here. Using the graph, find the values for which y is 1. It says g of x is 1. So that's along the line right here. So what I'm going to look for is what are all the x coordinates where that happens. Okay, so this point right here, I'm going to estimate this one. This is 16, by the way. I'm going to estimate this about, I don't know, -1.3. It also hits it right here, which looks like it's pretty much right at 2. It also hits it right here, which is almost to 3. Sorry, almost to 4. So I'm going to go like, I don't know, 3.8 maybe for the x coordinate. So that's your practice test, your review. Hope it helps. Sorry for little hiccups in there a little bit, but it's live. Don't go back and edit these things. Hope it helps you. See you tomorrow.